Hello there, folks, and welcome to another update on the eruption that just began yesterday on August 22nd in Iceland. I'm Geology Professor Shawn Willsey. Thanks for joining me. Did a couple of live streams last night as the eruption was beginning, and thought I'd follow that up with a quick update here about some of the things that have been going on over the last I guess 12 hours or so. It is about 8:50 a.m. Mountain Daylight Time, 2:50 p.m. over in Iceland. So just to catch you up to speed, we have our, I guess, sixth eruption of this series, the fifth this year, that's now begun as of yesterday, August 22nd. The eruption began about 9:27 local time in Iceland. Started out as a single point, progressed and lengthened into a fissure that was upwards of 4 kilometers in length. Luckily, there was some notice, there was an uptick in earthquakes, some borehole pressure changes at the power plant that were detected. That actually prompted the alert to evacuate both Grindavik, the Blue Lagoon, and the power plant. So everyone that was potentially in harm's way was moved and evacuated quite efficiently. So that's great news. And then after this fissure grew a few hours into the eruption, there was a second fissure to the north that opened up as well. We saw most of the action and most of the activity from the eruption at the north end of the fissure, which was great news for Grindavik because that meant that a lot of the lava and eruptive activity was confined further to the north and not towards the south and towards the town. One other interesting thing before we get to some of the videos here and the updates was that the interesting thing was that usually what we see after an eruption is we see a decrease in seismic energy and activity. As once that pathway's opened, the magma just sort of funnels and concentrates, follows that pathway, and relieves all that pent-up pressure by releasing it through that vent or that fissure. And what we actually saw was earthquakes increasing to the north, and what was happening was the fissure system, as it was kind of propagating and opening to the north, almost like a pair of scissors, if you will. That's how that second fissure opened up. So after the initial 4 kilometer fissure was created, it was odd to see more earthquakes clustered just to the north. And that was obviously a sign that there was still quite a bit of pressure in the subsurface magmatic system. And that pressure was pushing and forcing itself through some pre-existing fractures and older lineaments to the north, and then eventually injecting that magma there and then having it erupt to form that second fissure. So this is a live view from what we have right now. So let's go through some of the webcams. Last night everything was dark, and so we had the nice pretty glow, but couldn't really get our bearings as well. So I want to take you through the webcam, show you the map, and get everyone up to speed on what's been going on. The most interesting happening this morning is we can still see the fire fountaining and the fissure erupting here, but there's been an area along the fissure that apparently has been interacting with groundwater. We've had some groundwater magma interactions, and that's produced a pretty vigorous plume of ash and gas and steam that's been coming out of the ground. It's dissipated somewhat here, but let me see if I can take you back a little bit. Let's go to this camera here. And you can see it's still kind of outgassing here. The camera's jumping around a little bit due to the wind, but this is actually what it looks like now, so it's not nearly as vigorous now. But if I take you back a bit, maybe a half hour or so, you can see just how vigorous that phreatomagmatic eruption was. So this is, it looks pretty ominous and impressive, and it is, but in the grand scheme of volcanic eruptions, this is still quite small and quite localized. So basically what's happening here is some point just below the surface at probably a shallow level, the magma that's coming up has reached an intersection with fractures that are filled with groundwater. And so the groundwater and the magma are interacting in just the right proportions to allow that water to be heated up and flash to steam. That is an expansive process, and so that causes the magma that's there to just get exploded and burst out of the vent much more explosively than it would otherwise. So there's just this little local pocket along the fissure is behaving a lot more like what we might see from a more explosive type of volcano, the big cone-shaped volcanoes like in the Cascades or Mount Fuji or someplace like that. So it's fairly localized. It is decreasing the air quality. Luckily, the winds, I believe, are still coming out of the north, so this is heading more or less to the south. towards Grindavik, but the people have been evacuated from there, and so the air quality and the gases might be in high enough concentrations to be a health hazard there, but we have people out of harm's way. But nonetheless, that's what was going on a few tens of minutes ago. It looked like it was kind of at its peak, and if we go to what this looks like now, you can see it's much less explosive. There's still a little bit coming out here over here on this right end, so there's still a little bit of maybe interaction, although the energy of this plume looks a lot less vigorous than it did earlier. So it looks like it might be kind of winding down a little bit. There could still be some little bits of interactivity here and there. And if we go a little bit earlier than that, well, let's go maybe a couple hours ago, you could see there really wasn't much going on along that section. So this just popped up just as I was getting into the office this morning and looked at the webcam. This was like the main thing going on, and it kind of reached a peak maybe about half an hour or so ago. So about 8:30 Mountain Time AM, if you wanted to kind of check that again on your own. Let's take you through some of the webcams and let's actually start with the map. That might be a good place to start. So here the Met Office has a new map out showing exactly where the flow is, and the hash pattern here, let me maybe zoom in. Let's see the best way to do this. Probably something like that. This pattern here, the lines, this is the new lava flow, at least as of 3:30 in the morning. So the red lines here are the fissure vents. This is the main one, the 4 kilometer long stretch that opened up initially. And this secondary one to the north was the one that opened up after an hour or two once the initial eruption had begun. This popped up about an hour or two later and was preceded by quite a bit of earthquake noise and seismic activity. So you can see the extent of the lava flow both on the east side, which is not problematic because there's just a big valley here and then some steeper hills. This doesn't pose any threat to infrastructure here. On the south end, didn't really flow anywhere to the south. It was kind of running into this old shield volcano right here and really didn't have the topographically kind of favorable conditions to really flow anywhere else. And so thankfully none of that really made an advance towards the town and its defensive measures. On the biggest issue I think last night was we had a substantial flow to the west out of the fissure, and it looked for quite a time as if these flow lobes here, these 1, 2, 3 flow lobes, were going to, let me get you in a little bit closer to those perhaps. And then come back out just a skosh. Here we go. So here's the fissure here. Power plant Blue Lagoon off to the left here. And these 3 flow lobes here were the ones that looked like they were going to advance over the roadway. Again, remember this is the road that actually has been taken out, let's see, by the February, the March, and the May eruptions. So there's been 3 events that have covered this section of roadway. And it looked like it was going to happen again. But then the whole thing kind of stalled out a little bit, and fortuitously the energy for this eruption was mainly concentrated at this north end, and so we didn't see thankfully as much energy coming out of this section of the fissures, and so we didn't see as much of this lava flow advancing further to the south as we might have otherwise. So, and then finally we had this larger lobe here that kind of came around the north side of Stora Stogafeld, and then was advancing into this flat area out here, all the way out to this small little here, Lilla Skogafeld. And so that's kind of the state of affairs right now. So there's our map, maybe just showing you quickly on Google Earth. I tried to put in where the fissures were as best I could, just kind of eyeballing it, going back and forth from the map. I haven't put in the lava field yet, but this green line is the location of those fissures with that secondary set of fissures that opened up later up here. So you can see more or less where those were. And interestingly, those plot up really similarly to the December eruptions, at least at the north end particularly, almost parallel or right on top of it, more or less. And some parts of this new fissure system were very similar to what we saw in the March one, which is shown here in blue. So largely parallels that. So showing that it's using a lot of the same pathways. And then let's take some of these out. And then if we just look at the the May 29th eruption here. I guess I never put the fissure for that one in there. I just put the primary spatter cone in here. But nonetheless, you can see there's the February one with the red, December in orange, but largely following the same trend and the same pathways, if you will. Thankfully, it did not follow the pathway of the January eruption, which was much further to the south. But it seems like we have a this conduit that seems to have been developed that extends at least from about Hagefeld here all the way up past Storastogafeld, off to the northeast here. And I guess the eruption from yesterday, if anything, has lengthened the eruptive conduit further to the north, and that could be a problem in the long term. If the next subsequent eruption pushes this even further to the northeast, now we're reaching a point where the lava flows would be headed down towards this road, Road 41, Reykjanesbrau, which is the main road from the Keflavik airport over to Reykjavik. So having lava flows impact this roadway here would be a pretty big issue, pretty big blow to infrastructure and transportation and such. Getting people to and from the airport. This is probably, I don't know for sure, but I would guess this is one of the busiest roads in all of Iceland in terms of just traffic per day. Not to mention as well this little tiny town of Vogar, which sits over here. So, but that's a long ways off. But those are things maybe to look for as we move into the next eruption or two. Let's head back and just check out this eruption as it stands currently with just some of the various webcams here. So we can see that the fissure, predictably, this is what we typically see. Last night this was a solid curtain of orange and yellow just shooting out lava, and now it's starting to dissipate down to being confined to certain areas along the fissure. And we would expect this to go on for several days, maybe a week or two, and slowly diminish with time and become more concentrated into one or two specific locations. Once it gets a little bit more concentrated than this and just has a handful of locations erupting, we might start to develop the typical spatter cones that we've seen. Right now it's probably developing what we call spatter ramparts, which would be a ridge of accumulated lava that's actually been thrown out of the vent that falls adjacent to that fissure and builds up a big levee, a berm of coagulated lava along the margin of that fissure. So probably developing some spatter ramparts, but also feeding these flows, which probably aren't going out too far, at least right now. So we'll just check all the webcams real quick here. Looks like that phreatomagmatic activity died down quite a bit from what it was maybe an hour or less ago, but still I can see a little bit of darker ash still coming out there. So you can tell a little bit what's going on by the colors, the kind of bluish color here. This would be the sulfuric gases that are coming out of the magma. But this darker material here, that would be more indicative of rock being broken, lava being shredded and pushed out with extreme force by that expansive force as that water flashes into steam. Another view here, make sure these are all kind of live. So this one's looking more or less to the northeast, but you can see the main fissure still has a little bit of eruptive activity here, but that northern one, the new one that opened up, that's off to the left there, and that's probably got the lion's share of the lava that's erupting right now. So this main fissure here, which was very active last night, looks like it's died down quite a bit. Big view from further away. Can't really see the lava as well, but you can see some of the gases and I guess some of that ash as well. This would show, last night this showed the advance of the lava flow to the west. This is the power plant in the far left bottom corner here. Camera's jumping around because of the wind. You can see the roadway here, and there's a little bit of still outgassing from this flow here, but it looks like, as far as I can tell based on all the data, that this lava flow has largely stalled, probably because it's fed by this more central part of the fissure, which has died down quite a bit. So I'd say it's looking like we shouldn't see this lava flow advance a whole lot more than it has if this kind of activity continues. Another view towards the same sort of thing, lava flow in the distance, but the bigger the bigger fissure and vent is around the corner off to the left here. These are just some older craters here that are just kind of steaming away. Um, and yeah, this is kind of looking back up the hill. This is looking at some of those little steaming hills right here. So we're looking from the far right side of the camera here and looking back more or less due north towards the active fissure there. And then one last view here, similar to what we kind of already saw there. So let me just walk you through a few other things here. We've looked at the map. So that's up on the Met Office website. That's a great reference there. And again, the diagonal black lines here shows the extent of the lava flow. I know I have one viewer out there that sent me the shape files for these, and if you could do that again, if you get time, that would be great. I could add that to Google Earth so we have the outline of the lava field. Maybe not now, but once it looks like it's pretty stabilized. This might grow a little bit more, especially at the north end here where we have a little bit more activity that's still ongoing. These flows could push on beyond their current boundaries as shown here. They probably already have. This was as of last night, but as that activity winds down a little bit, we might see that dissipate even more so. Let's go to the actual last update from the Met Office, which was at 11:45 a.m. Iceland time. So activity further north than in the last eruptions. We talked about that. The earthquake activity that we saw last night has gone down considerably, and I'll show you that here in a second. I'll also show you some great graphs and plots put together by one of our viewers, Bruce Garner. He sent me another email with some great graphs and things I think you guys will enjoy. Gas pollution will reach the south and southeast. Not a problem though, because that's an uninhabited area. The road's closed. People are evacuated from Grindavik, so shouldn't be an issue for now, unless the wind changes. Let's see what they have here. At the beginning of the eruption, the fissure between Stora Stogafelt and Sunnuk opened just like in the last volcanic eruptions. During the first hours, the fissure extended continuously to the northeast until about 5 or 6 this morning. At the same time as the eruption moved northeast, the activity in the southern part decreased and now erupts from a fissure in the area from Stora Sogafelt and from there to the northeast for about 2 to 3 kilometers. So that southern end's really kind of died out for the most part. When activity on the fissure moved north, the flow of lava slowed towards the road and the power plant, which was good news. The main current of lava is therefore to the northwest, north of Stora Stogafelt. So, I mean, really turned out pretty well so far. The town, totally fine. And the lava flow that looked like it might be a bit of a threat to the power plant in the Blue Lagoon has stalled and looks like it's pretty much done as well. So I think so far this eruption from just the infrastructure standpoint has gone about as well as it could. Continuing with the update, along with the lengthening of the fissure, there was considerable seismic activity and deformation around the fissure. After about 4 o'clock this morning, the seismic activity decreased significantly and the deformation also slowed down, which fits well with the development of the eruption. So they've got a simple graph here and a map that shows, let's start with the graph. This is actually earthquakes per hour. So, around 10 o'clock. So here's the earthquakes kind of spiking as the eruption gets going. Then they drop a little bit, but then they spike back up. Normally what you would see is this thing just dropping down as the eruption and that vent and the fissure opens up. We see the secondary spike here though, because that was the development and the opening of that second fissure to the northeast. And so that to open that fissure, it takes earthquakes. We have to break the rock, widen the fractures in the rock in order to allow the magma to come up. The magma pressure is what's causing those fractures to widen and break. And so we see this secondary spike in seismic activity due to that. So that was the cool kind of odd thing that kind of caught me off guard a little bit yesterday, was like these earthquakes that were popping up in that area. And I'll show you the earthquake data here in just a second. Although they have it plotted up right here. I'm not sure what the time frame is on this. We could look at the caption real quick. Yeah, so this is the same. Okay, so they've just plotted up these same earthquakes here on the graph from 10 o'clock last night onto this morning are just plotted up here on the map. And so you can see, even though the vent, the primary 4-kilometer vent was from about here down to this point, there was this whole cluster of earthquakes to the northeast that were associated with the development of that secondary fissure that opened up. And now we're seeing those die down, which is good news. If we kept seeing these moving to the northeast, you might see the magma kind of chasing and following that, and that could be bad news for the roadways and some of the infrastructure to the north there. So let's look at those earthquakes. So here's a plot of the last 2 hours. Here's Grindavik down here, nothing. So there's not been one earthquake recorded in the last 2 hours, but when we throw in the whole last 24 hours, you get a whole lot. And so we can kind of weed some of these out a little bit here, just to make sense of this. Let me kind of get it all in view. There was one exceptionally large quake in the mess of this. You can probably pick out that red outline. That's a 4.1 in there, but we could weed out everything. Let's say this is all above magnitude 1. Let's just look at the 2s and above, which is still plenty busy. And maybe just down to like the last. So this would be everything for the last 24 hours. If we pick maybe the last, trying to pick the right time frame here, maybe the last 10 hours or so. Boy, that gets rid of them all. Maybe 16. Yeah, so then they kind of pop up there. But you can see, even though the vent was further down here, here's Stora Stogafeld. This is actually a good time frame here. At 16 hours ago, the eruption, I believe, had begun. Yeah, the eruption had begun, but the activity in terms of earthquake was concentrated more to the north, and this was associated with that secondary fissure to the northeast that opened up there. So again, kind of adding in, if we go back, 20 hours or so, it's going to add, more of these quakes down in this area here. So the earthquake story was pretty interesting in watching that last night, more or less, kind of in real time as it was playing out. So we saw the earthquakes happening, and then that was the magma actually pushing its way through and then breaking open a new vent and a new area there. Apparently the 4-kilometer vent wasn't enough. There was still more pressure in the magma system. Remember, we've stored a tremendous amount of magma in the subsurface over the last few months, upwards of 22 or so million cubic meters of magma. And that 4-kilometer vent, if that can't satisfy the demands of pressure in the subsurface, then that sometimes necessitates opening up another vent and more space for the magma to move that's under pressure. And that's apparently what happened with this eruption that we saw yesterday. The GPS data shows what you'd expect. So here's our Svartsengi station. Let me get my little head out of the way here so you can see that last data point. And here it is ramping up through the end of May into June and July, and going into August. It was kind of slowing down a little bit here, going up, slowing down, and then the eruption dropped it back down. So we've got that one data point. This is the 8-hour run that's dropped the elevation of this station about, what's that, maybe about 160, maybe 200 or so millimeters. So about 20 centimeters, something like that, a couple inches. And so you can see that drop in elevation. And we'd expect this to stabilize over time. And then once the eruption dies down, we will more than likely see this start to pick back up again. If there's more magma influx into the system, then we'd expect to see this start to move up as we start reinflating and refilling the magma storage zone. So that's just one point there. But we can grab any other of the stations and you can see similar sort of thing. So the drop here, this is the Eruption station, movement to the north and movement to, interestingly, the east. So this station moved to the northeast after the eruption. So it was swelling and moving to the west, and then it's moved back to a position before inflation. Let's see. That's just some of the news. No infrastructure and immediate danger. News and notes here. Some of the stuff Amanda Joe sent me here. And I think that's about it. Let's go back and just maybe check a few of the webcams. So moving forward, what can we expect from this eruption if we use the past eruptions as a good starting point and an analogy? We would expect this fire fountaining to diminish and decrease over time, localize, and possibly form several or possibly eventually just one primary spatter cone, more than likely in this northeast section where the activity is more vigorous. This central section here is likely to be the first to die out, although it still has a little bit of activity that's ongoing right here. So this northeast section is the one that's likely to persist a little bit longer. It could continue to feed some flows that might advance a little bit further than what we have in this mapped area here. So I'm sure the Met Office will keep updating this map with a new lava flow outline on this here. We would expect the earthquakes have already dropped off to essentially zero, and I'd expect that to continue. And the GPS has dropped, and we'll have to see what the elevations do moving forward. More than likely, they'll kind of be stable for several days, not really doing a whole lot. And then once the eruption dies down, we might see those start to pick up a little bit. But for now, it's a spectacular eruption, and I think all things considered, it turned out as well as it could in terms of the possible threats to the infrastructure here. Again, my primary concern is moving forward as we kind of move past this eruption and start to gear up for the next one. Now that we know that this magma body has established a pathway to the surface, a conduit that extends at least to about this point here, which is further than it did previously. Remember, the furthest we saw it come in the December eruption was maybe somewhere in here, and hadn't really gone that far north in a while. If this continues to propagate further to the northeast, those lava flows that might come out of those future fissure vents would be moving down slope, which is towards the sea, towards this critical road here from the airport into the capital city, and possibly towards these small villages here. But this is a long ways off. There's things that could be done, so it'll be interesting to see if they're, we've got these defensive berms and measures in place around these two pieces of infrastructure, and what might be done here. Now the roads, you can't really, if you protect the road in one section, the lava is going to have to go over the road somewhere. But it'll be interesting to see if maybe they already have, but as far as I know, they've not done anything for the small town of Vogar to provide any sort of barriers or defensive mechanisms or any sort of mitigation structure. So that could be the next thing, the next point of emphasis from the Icelandic community. So we'll have to see moving forward. So hopefully this was a helpful update. Thank you for your support of the channel and the great community of geology learners we have here. Thanks as always to Amanda Joe for sending me so much great information and helping me get these organized. And I will be back with you as soon as there's something substantial to look at. It could be later today, could be sometime this weekend. But have a good one, and we'll see you later. Take care.